All right, so now we're taking a look at the examples at the bottom of page 6. Now, I started them off a little bit so that we can get a little bit more done. You know that the three angles in a triangle have to add up to 180 degrees. Well, a shorter way of doing this is, since you know that we have a right-angled corner there, which is 90, the remaining two angles must add up to 90. In other words, y is going to be equal to 90 minus 52 equals 38 degrees. In the next question, we're already using the idea of the three angles adding up to 180. So the angle at the top there is 130 degrees. And I've set up the fact that these are vertically opposite angles. Vertically opposite looks a little bit like a bow tie, okay? And so those two angles must be equal to each other. X is equal to 130 degrees. Then we can use the concept of supplementary angles so that angle X and angle Y must total up to 180. And so the missing angle for y is going to be subtracted from 130, subtracting 180 minus 130, and so y is going to be equal to 50 degrees. Letter I is starting off with the concept of supplementary angles. Therefore, x must be equal to 43 degrees so that those two angles total up to 180. Then I need the concept of finding this missing angle in the corner, which is the result of subtracting 102 and 43, their total, from 180. So that's equal to 145, and the missing angle is 35 degrees at that bottom corner. And then we use the concept of supplementary again. That wasn't the measure of angle y we just calculated. Angle y is out here. And the measure of angle y is going to be equal to 180 minus the 35, which gives you 145 degrees. Letter J. Now here, these three questions are asking you about angles, parallelograms, parallel lines, working through the measurements. So we're trying to spot those special characteristics of corresponding alternate or co-interior angles. So question A, we have the concept right away of supplementary angles so that you can figure out that the measure of angle A is going to be totaling with the 54 to equal 180. So angle A is going to be equal to 126 degrees, subtracting 54 from 180. Then looking at question B, we have the corresponding angles. So angle B must be equal to 90 degrees. It must match the angle down at the bottom using the corresponding, that upside down F. Letter C is when we're looking at the Z property, okay, the alternate interior angles. And so C must be equal to 54 degrees because it's going to equal the angle on the alternate side of that transversal crossing the parallel lines. And then we have complementary angles, which are basically adding up to 90 degrees. The angle D and angle C added together have to be 90 degrees. Because they are beside another 90 degrees. Those two angles are, two lines are perpendicular. Therefore, D must be equal to the complement of 54, which is 36 degrees. Letter K. We start off right away to find the value of angle A. Supplementary angles add up to 180 degrees, so A must be equal to 61 degrees. Angle B, we have the idea of perpendicular lines again, and so B must be equal to 90 degrees. We have a Z going on as the measurement or the relationship between angle A and angle C, and so they must be equal to each other. Angle C is equal to 61 degrees, and C and D are supplementary, so D must be equal to 119 degrees. Letter L, we have the measurements, we have this co-interior idea, and so the co-interior angles have to sum to 180. So in other words, 115 plus the 35 plus the Z, okay, those two angles together are going to add up to 180 degrees. So using a little bit of guess and check, or maybe some algebra, or simply, adding and then subtracting, we're going to find out that Z is equal to 30 degrees. Z is vertically opposite from the y, so y is also going to be equal to 30 degrees. And angle X is vertically opposite from the 35 degrees, so X is going to be equal to 35 degrees. So hopefully you can follow all of that, and it's not going to be too difficult to apply these to different problems.